Hi there! In this video, you and I will be creating this scalable multiplayer web game. The idea behind it is fairly simple. A block stacking game where you score better if you stack higher. And to give credits where it's due, our version is a forked and improved one off of the original by Feldhaus on GitHub. Their version was a lot simpler. It only calculated the score based on how many blocks you stack. We added a global online leaderboard to keep track of top players, a previous game score history for a single player, and visual and audio effects to make the game more immersive, plus a simple anti-cheat system at the server level. The project splits into a front-end website that hosts the actual game, and a backend API with a database to store and manage leaderboard scores. This is a full-scale project that needs to be hosted for millions of players to reach. Using serverless architecture and a proper scaling and load handling approach is a must. However, using traditional ways to host and manage it would take a long time and require lots of efforts. Solutions like Taubyte are a no-brainer, an open source platform as a service that offers all of the above plus the ability to develop locally and ship to production with almost no configuration, and avoiding vendor lock-ins. There is a full YouTube playlist called The Hitchhiker's Guide to Taubyte that goes through the platform and gives a step-by-step detailed video on each feature. You can check it out to understand more. To follow along with this video, you must fork the repo on the Taubyte GitHub, link in the description. That way you can utilize webhooks and Taubyte's built-in CI/CD support. Let's take a look at our front-end code. Index.html contains the main HTML structure with the game container and model dialogues. Source main.ts is the application's entry point and event handler setup. Source game.ts consists of the core game state machine and block placement logic. Source block.ts has the 3D block physics and collision detection with the cut method and block placement with the place block method. Source stage.ts initiates the Three.js scene, camera, and rendering setup. Model.ts has the UI model system for name input and game flow. Global leaderboard.ts displays global leaderboard component and renders scores. The source services leaderboard.ts is the file where our frontend interacts with the backend. There are three main functions. The first one is the get global leaderboard, which gets all the entries from our backend. The second one is get player score, which gets a score for a specific player provided with a player name parameter. The third and final one is the submit score from state, which submits a full game state to API/score. Then the backend computes and stores the score. Source audio.ts outputs web audio API for sound effects and music. Source achievements.ts is the achievement system and milestone tracking. Ticker.ts is the game loop with 60 FPS timing, and .taubyte build.sh and config.yaml are the Taubyte build script for deployment and the Taubyte deployment configuration respectively. That's behind the scenes of our game. Let's kick things off by running it locally. Taubyte makes it easy to develop locally, then ship to production with Dream, another one of their solutions that simulates a Taubyte cloud locally. After you install this tool, run the Dream New Multiverse command to start your own cloud locally. If you get the success message, connect to it using the online console at console.taubyte.com. Enter your email and choose Dream/Blackhole to select the local cloud you just made. Use GitHub to log in. It will be used to create repos and make code changes through the console. This interface allows you to import already made projects and create new ones. I'll create a new one and name it Tower Blocks Game. Description is optional. Make this repo private and click Create. If no errors are present, then you will be directed to the main dashboard. Head to Applications and create a new one. I'll name it Frontend and validate. Applications allow for code separation and help with resource scoping. Let's add a website to host our game. We have an option to create a new repository using templates or link an already existing one to avoid repetition. That's what we're gonna do. Select the Fort Game repo on your account from the dropdown, then use Cloud Generate Domain for testing and add a /path as a website entry point. These changes are stored only in the browser. Let's push them to GitHub and copy the ID and full repo name whilst doing it. They'll come in handy shortly. Click Next, add a commit, and finish. Since our GitHub can't reach our local cloud, a manual build trigger is needed. Head to the terminal and use Dream Inject Push All and Dream Inject Push Specific, along with the ID and full name to trigger a config, code, and website builds. Check if the builds succeed in the build tab, then make sure you add the new domain to your etc/host file for easier workflows. Testing our website now is down to clicking the lightning button on the right side of the website. And here you go, the game is up and running. If we play a game, however, you'll notice that visual and audio effects are working, but the global online leaderboard is not. That's because we don't have the logic or the backend created yet. Continuing our workflow, let's create another application. Name it backend to host the game API's logic and validate. To store our data, create a database inside our backend application. Speaking of databases, Taubyte uses a path-style database where you store and retrieve data based on paths like a file system. I'm gonna name it leaderboard, set the matcher to /leaderboard, and a 100 megabyte is gonna be more than enough for this application. Libraries are a pretty convenient way to handle code inside Taubyte. They eliminate repetition and facilitates building and maintaining the code. We're gonna use one here to hold all our API endpoints logic and name it API_leaderboard. Validate and choose an empty Golang template. Libraries in Taubyte have the advantage of distinct repos. Open our libraries repo and let's go through the code. If I write the code word by word, it will take a whole other video. I'll just paste it and go through it with you. First thing first, we imported the packages we need, then created a fail helper function to send errors and status codes. We declared the data structures that we needed to represent 3D vectors, single game events, and players' game submissions. We have a compute score utility function and our exported main endpoint functions, starting with the getAll function. It parses the HTTP request, then opens the database, lists all the keys and sorts the players. It collects the players' entries, then sends them back as JSON objects. The second export is the get function. It returns one player's score provided with a player name parameter. First, it parses the HTTP request and extracts the parameter, opens the leaderboard database and looks up the player name. If found, it sends the related score back as a plain response. Finally, the last export is the set function. It submits and updates player's score if higher than the existing one. It parses the request and opens the database, decodes the request JSON body into game states, and it validates inputs and computes new scores using the compute score function. This function calculates the player's score based on the request data. First, it performs a simple anti-cheat check. It checks if the timestamps are chronologically correct. Anything suspicious would raise an error. If the events look fine, it calculates the score. So the score is simply the final blocks count minus 1. If the result is negative, the score is forced to be 0. Now this is a simple anti-cheat system, but it's for the sake of example. Checks the existing one and only updates if the new score is higher, then responds with success. I'll rename the file for organization purposes. Add and commit the changes, then push them to GitHub. Our next step is to use the library we created to add the endpoint functions. Switch to Functions tab and create. The first one is the getAll serverless function. I'll set the timeout to 20 milliseconds and the memory to 10 megabytes. Use the get method and select the generated domain. I chose a path of API/leaderboard. Choose the source as the library we created, and the entry point is the name of the function we exported in our library earlier. Let's do the same for the get function, except change the path to API/score and choose the entry point of get. Last function will be almost the same, just change the method to post and the entry point to set. Add and commit the changes, then push them to GitHub. Again, we need to trigger a build with the Dream Inject Push All, then the Dream Inject Push Specific command. Head to the library's YAML and get the ID and the full name of the repo. Use them in the terminal with the Dream inject push specific command. Then if you check the local cloud logs, we'll find that the cloning and building have succeeded. Taubyte has a way to separate the applications by giving a distinct domain for each. I will change the backend domain to match the frontend one so that both have the same origin. Dream inject push all to trigger global builds, then start testing the backend. The get all functions work, but since we haven't played any game yet, there are no entries. Let's change that. I'll play the game once. Testing the get function now, providing the same name I used in the website, returns my score. And that confirms all the functions and database working properly. All that is left now is to push to production. It's a really simple process that starts with logging out of the console. Make sure to have an already set up cloud online with Taubyte installed and use your email and its domain name to enter the console. Instead of creating a project like we did earlier, we're gonna import the local project from GitHub this time. Select from the dropdown and click import. Open the project and change the application's local generated domain to a production one with one simple generate domain toggle. Do this for both the frontend and the backend domains. Make sure you push your changes to trigger a config build. Notice that we don't need to Dream inject push all or Dream inject push specific since we're in the cloud, and GitHub can actually detect our nodes online. If we import a project that has a library or a website, we need to register the resource on auth before being able to trigger a build for these resources. This can be achieved on the web console using the broken heart next to the resource. Let's do that for our website, then do it for our library. Opening our game now is working properly, and all the features are up and running. I urge you to try this yourself to understand more. Play around with the project and feel free to ask questions down below or in our Discord server. I hope you enjoyed this and have a nice day.